Today, I want to go through simplifying radical expressions. And if you haven't yet, you should check out the interactive activity linked on the Moodle site. It's not very long, and if you're struggling with this topic or you just want more practice, I think you'll find it useful. So that's the idea here. Every number that's not a prime can be factored into primes. For example, take the number 100. 100 is even, so it's divisible by 2. And that's 2 times 50. 50 is also even, so we'll divide that by 2. And now I get 25. 2 times 25 is 50. 25 is not divisible by 2. It's not divisible by the next prime, which is 3, but it is divisible by 5. 25 equals 5 times 5. And we collect all these together, 5 times 5 times 2 times 2. The prime factorization of 100 is 2 times 2 times 5 times 5. First, we'll need to know how to find the prime factorization of a number. If you recall, a prime number is not divisible by any whole number except itself and 1. 1 is prime, 2 is prime, 3 is prime. 4 is not prime because 4 is divisible by 2. 5 is prime. 6 isn't prime because it's divisible by 3 and 2. 7 is prime. 8 is not prime because 8 equals 2 times 4. And the prime factorization of 8 would be 8 equals 2 times 2 times 2, where it's written as a factor of primes. Let's do another one, maybe 252. The way this works is you try to divide it by the smallest prime you can. If it's even, that will be 2. If you can't divide by 2, try 3. Then try the next one and the next one until you've found the smallest prime that goes into your number. This one's even, so first we'll divide by 2, and that's 126. 126 is even, so I'll divide that by 2. 2 times 63. I can't divide by 2 anymore, so let me try 3. 63 divided by 3 is 21. 21 is not even. 21 divided by 3 is 7, and 7 is a prime. So I'm done. I collect all of these, and the prime factorization of 252 is 2 times 2 times 3 times 3 times 7. Now, to simplify a root, we break the number into prime factors. If there are enough factors to escape the root, we can pull them out. For example, if I want the square root of 252, that's the square root of 2 times 2 times 3 times 3 times 7. 2 times 2 is 2 squared. The square root of that is 2, so I can pull 2 out. I have 2 3s as well, so I can pull a 3 out. I only have 1 7, so I'm going to have to leave that in there. The final result will be 2 times 3 times the square root of 7, which is 6 square root 7. And you can check on a calculator that 6 times the square root of 7 is the same as the square root of 252. Let's say I wanted the cube root of 252. Well, none of these numbers are in a group of 3, so we can't pull any of them out of a third degree radical. This can't be simplified any further. But if we wanted the cube root of 16, then the prime factorization of 16 would be 2 times 2 times 2 times 2. There are 3 2's here. We can pull a 2 out, and the final answer would be 2 cube root 2. And that's the way simplifying works. In order to pull something out of the radical, it needs to occur in a group that's the same size as the root. And if we have a variable raised to a power, like x cubed, that separates into x times x times x, and we can pull out groups of variables as well. Let me go through a few of these examples, starting on page 89 of the packet. The cube root of 189. First, let's try to factor 189 into primes. It's not even, so we can't divide it by 2. Let's try 3. 189 divided by 3 is 63. We can divide 63 by 3, and that gives us 21. Divide that by 3, and we have 7, which is a prime. The cube root of 189 equals the cube root of 3 times 3 times 3 times 7. I have a group of 3 3's under a third root sign, so I can pull out these 3's, and that will give me 3 times the cube root of 7. The square root of 27 times c to the 5th. Okay, 27 is odd, so first we try to divide it by 3. 27 is 3 times 9, and 9 divided by 3 is 3, and that's our prime factorization. The square root of 27 times c to the 5th is the square root of 3 times 3 times 3 times c times c times c times c times c. And because it's a square root, we're looking for groups of 2. We have a group of 2 3's, a group of 2 c's, and another group of 2 c's. And then what's left is a 3 and a c. So what we have is 3c squared, square root 3c. The third root of 40 times h to the 5th. Now we're looking for groups of 3. 40 is even, so first we divide by 2, and that gives us 20. Divided by 2 is 10. That's even. We divide by 2 again and get 5. 5's a prime. That means the prime factorization of 40 is 2 times 2 times 2 times 5. We also have 5 h's under the radical, so that's times h times h times h times h times h. Because this is a cube root, we pull something out whenever it occurs in a group of 3. We have 3 2's, 3 h's, and then no more groups of 3, so everything else gets left under the radical. We have 2 times h times the cube root of 5h squared. I'm going to skip a few of these and do the last two. The fifth root of 192 times q cubed times s to the fifth. First, let's factor 192. It's even, so we divide by 2, and that's 96, which is even. 48 is even. 24 is even. And 3 is a prime. We've finally got our prime factorization. Two times 2 times 2 times 2 times 2 times 2 times 3 times q times q times q times s times s times s times s times s. We want groups of 5. There are 5 2's here, 5 s's here, and everything else gets left in, so we'll have a 2 times 3 times the 3 q's. And we pull out a 2, we pull out an s,